Let us solve one problem from JEST Physics 2024 question paper. So the problem states that two trains, each having proper length L0, are moving towards each other with the same speed v, but in the opposite directions as measured by an observer in an inertial frame. What is the length of one of the trains as measured by an observer in the other train? Right, so we need to find the length of the train with respect to that observer in the other train. Two trains with the proper length means the rest length is given. L0 is the rest length of the train. Two train, and each are moving with each other with the speed v. So both the trains, train 1 and train 2, are moving with the speed v, right, towards each other. So so the speed is measured by an inertial observer O. Let's say O here is mapping. So we want to find that if any observer is sitting in one train, what he will measure, he or she will measure the length of this train with that a observer who is sitting in any of the train, what length will measure with respect to him. So we use the relativistic velocity addition. So for the use relativistic, we use the relativistic velocity addition, since the relative velocity of the other train is not just 2b, but instead it will be v real will be v plus v into 1 plus v square by c square. So it will be 2v plus 1 plus v square by c square. So we will use the length contraction formula. So relative, we can use the length contraction formula. We can write that L equal to L0 into root over 1 minus v square by c square, right. So but here the relative speed means v can be replaced by replacing v with v real. So this expression becomes L0 1 minus v real square by c square, right. So putting the value of v real from this above equation, we have L equal to L0 into 1 minus 1 by c square into 2v 1 plus v square by c square whole square. So if we take in the numerator, so it will be L0 into 1 minus 4v square by 1 plus v square by c square whole square into c square, right. Multiply seeing in the both the numerator and the denominator, we have L equal to L0 into 1 minus 4 v square c square by c square plus v square whole square. So if we calculate, it will come c square minus v square square by c square plus v square square, and finally L expression will be L equal to L0 into c square minus v square by c square plus v square. So this is the ultimate expression, which is the required dilated length of one train as seen by a observer in the another train. So this matches with the option A of our given problem. So the option A will be our correct answer. So thank you for now.